Okay, so let's say if you wanted to divide those, you actually still could use synthetic division. Since x plus 4 is just x minus negative 4. So you can still rewrite it and use synthetic division. Okay. Now the time you can't use it is when you have something in front of your x. So if you have, let's say, 7x to the third plus 2x squared plus 5x plus 9 divided by 3x plus 2, because of that 3, remember here it has to be x minus something. So because of that 3, you can't use synthetic division for this problem. You'd have to do long division. So you cannot use synthetic division here because the denominator is not in the form of x minus k. All right, does that make sense? All right, and once you see synthetic division, you're going to wish you'd be able to use it on each of them, but because it's really, really fast, you can divide it in like 15 seconds. It's really quick. Excuse me. All right, so anyone still? Oh, I'll leave it up for a few more seconds. All right. So let's say, for example, once you use synthetic division to divide, oh, actually, first let me give you the kind of the steps for synthetic division. So we'll save that one. Steps for synthetic division. Okay, so let's say if we're going to start with a polynomial of degree 3. So to divide, let's say ax to the third plus bx squared plus cx plus d by some x minus k. Okay, so we're going to use this pattern. Okay, so you're just going to write the coefficients. So let's say coefficient of x to the third is a, coefficient of x squared is b, coefficient of x is c, the coefficient of the last one is just d. Okay, draw kind of an upside down division bracket. And your x minus k, you're going to put your k right there. Okay. So your first step is you're just going to bring down that first coefficient. So you're going to bring down that a. And then you're going to multiply these two together. So you have k times a, and you're going to put it right here. And you're going to add these two together. So you multiply these two. That goes here, and you add. Okay, so let's say you add these together and you get some value of f. Okay, now you multiply k times f. So you have k times f. You add them together, and let's say you get some value of g. Now you multiply k times g. You add them together, and whatever value you get here, that's your remainder. Okay, So remember here, you just write your coefficients. I guess you could say coefficient of numerator terms. Remember the x minus k, that's your denominator. Oh, why is that over so far? Okay, so let's use this on an actual example. All right, so let's say, for example, use synthetic division to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. Okay. Now, two things you have to remember for this one. The first is the exponents have to be in descending order. So you're missing an x to the third. So you have to fill it in with the 0x to the third. Okay, so you want to remember up the numerator has to be written in descending order. Or numerator exponents. Okay, so that means we have to write that as x to the fourth plus 0x to the third minus 10x squared minus 2x plus 4. Okay, so we already know we have that taken care of. And we also have to remember that it has to be in x minus k form. So denominator must be in x minus k form. Let me clean that up a little bit. There we go. So that means x plus 3, you just have to rewrite that as x minus negative 3. Okay, so that means we're going to have x to the fourth plus 0x to the third minus 10x squared minus 2x plus 4 divided by x minus negative 3. Okay, now this is your k value. Because remember, it's x minus k. All right, so it doesn't look like a whole lot of room left, but trust me, that's more than enough room to do this one. Okay, so you're going to write all of your coefficients. So this, remember, that coefficient is just 1. So you have your k, which is, in this case, is negative 3. Write your upside down division bracket. Your first coefficient is 1, so you're going to write a 1. The next one is 0, so you write a 0. The next one is negative 10, so you write negative 10. The next one is negative 2, so you write a negative 2. And the last one is 4, so you write a 4. Okay, so remember, your first step is to bring that first coefficient down. Negative 3 times 1 is negative 3, so you put it there, add those two together. 0 plus negative 3 is negative 3. Okay, so now you multiply negative 3 and negative 3, you get 9. Add those together. Negative 10 plus 9 is negative 1. Now you multiply negative 3 times negative 1, which is positive 3. You add those together. Negative 2 plus 3 is positive 1. You multiply negative 3 times 1, which is negative 3. Add those together. You get 1, and that last 1 is your remainder. Okay, so it's just a process of once you bring down that first one, you multiply, bring it up to the next one, add. Multiply, bring it up to the next one, add. Okay, so this, remember, these are all of your coefficients. So this was your x to the 4th, x to the 3rd, x squared, x, and this is just your constant. Okay. Now your answers down here, this will actually bring each one of those exponents down 1. So if this was x to the 4th, this would be x to the 3rd. If this is x to the 3rd, this would be x squared. If this is x squared, then this one would just be x, and that means this one is just your constant. Okay, so that means if we wanted to rewrite this as x to the 4th minus 10x squared minus 2x plus 4 divided by x plus 3, we know that's equal to 1x to the 3rd, which is just x to the 3rd, minus 3x squared minus 1x plus 1. Nope, forgot, I missed my x to the 3rd. X to the 4th, x 3rd, x squared, x, yep, plus 1. I was right. Plus 1 with a remainder of 1 over x plus 3. Clean that 3 up a little bit. There we go. All right, so that's how you use synthetic division. That's why if you see just how little space we needed, it's really, really quick. Okay, but it only works if there's nothing in front of your denominator's x value. All right, any questions on that one? All right, so we're actually going to be using synthetic division over and over and over. Anyone still writing? Nope, looks like everyone's got it. We're going to be using synthetic division over and over and over, so you'll get plenty of practice. Okay, so we're going to use synthetic division to cover what they call the remainder theorem. Okay, so if you have a polynomial divided by x minus k, the remainder is r equals f of k. Okay, and I'll show you how that actually comes into play. Okay, so let's say, for example, if you want to use the remainder theorem, that should be capitalized, but no big deal since it's a name. Remainder theorem to evaluate f of x is equal to 3x to the 3rd plus 8x squared plus 5x minus 7 at x equals -2. Now we're not dividing, we're just actually going to find out the value of f of x equals -2 using synthetic division. Because normally you just plug in -2 and do all the calculating and everything else, but you don't have to.